So here we'll be discussing about the reduction of nth order equation, nth order ODE, ordinary differential equation, into system of first order ODE. Okay, see what is the speciality, because see nth order equation means obviously it is a bit complex, okay, whereas the first order equations are very easy to deal with. Okay, in fact we are considering equation with constant coefficient. Okay, so while considering this nth order equation, it is more complex, whereas this first order equation, it is simpler. Okay, so that is one of the biggest advantage. Suppose you consider one real world problem, real world application, or the governing equation, if it is in terms of, suppose, nth order equation. So nth order equation means if it is of this form, yn plus a n minus 1 by n minus 1 at derivative plus so on, it will go a1 y dash plus a0 y is equals to, suppose, ft. Suppose this is the governing equation, which is a real world problem where you have this nth order equation. Now if you want to solve this equation, that is okay, you can go ahead with the solution technique. But another way or another approach is to convert this equation into a system of first order equation and then go for the solution for that first order system. Okay, so how we can convert this type of equation into system of first order equation. See, solution technique already we learned, that is by applying matrix method, and then solution by applying the technique of diagonalizability, okay, or diagonalization. And third method we learned, if the initial conditions are prescribed, then we had Laplace, okay, Laplace transform. So these are the method by which one can easily solve that first order system. Okay, now see this one example we can take, and through the example we'll try to understand the concept or the technique by which we can reduce this equation. Suppose this is the equation we are considering, so we should introduce x1 is equals to y, okay, and suppose x2 is equals to y dash, and so on. xn is equal with y n minus 1th derivative. Okay, and immediately this equation can be expressed in terms of these variables. Now we can take, see, this is the initial setup. Here you can see this equation, it is of nth order equation, and we are considering the variable, see, xn, that will be yn minus 1th derivative. Okay, similarly xn minus 1, that will be yn minus 2th derivative. Okay, like that. Okay, so here if I consider one problem, suppose this is the first problem I'm taking. Consider the equation y double dash minus 3y dash plus 2y is equal with, suppose 0 I'm taking. Okay, convert into system of first order ODE. Okay, then solve using matrix method. This is a direct question I am giving, but you can expect some physical problem where the governing equation either you have to formulate or it will be given in the question. Then this technique of conversion we'll see. And after that, the matrix method already we studied, you can check out. Now see, solution. Here this is the equation y double dash minus 3y dash plus 2y is equals to 0. Just now what we stated, this conversion technique, see, it was an nth order equation, so we introduced this variable like this. Okay, so similarly here we'll be taking x1 is equals to y, take x1 is equals to y, and suppose x2 is equals to y dash. See, if this is equation number 1, then this equation 1 can be written as y, see, x2 dash minus 3 x2 plus 2 x1 is equals to 0, which is nothing but x2 dash is equal with 3 x2 minus 2 x1. Okay, from this setup one can easily write that this is nothing but x1 dash is equal with x2. Okay, now see this system, see this one, that is x1 dash is equal with 0 x1 plus x2, and x2 dash is equal with you can write like this, that is minus 2 x1 plus 3 x2. Okay, so if you refer to this system, see, this is a first order system which already we are familiar with. Okay, this system. Now this is the answer for first part. Now if this system you want to write in terms of matrix, in terms of matrix representation, that is x dash is equal with a x, where this a, it is given by 0 1 minus 2 3. Okay, and this x, it is given by x1 x2. Right, now you can solve this one and you can get the eigenvalues first by applying this matrix method. Means first eigenvalues, suppose the eigenvalues are lambda 1 and lambda 2 you are getting. Okay, corresponding eigenvector, it is v1 and v2. Already we have studied this matrix method. So here eigenvalue first work, then eigenvector, and finally the solution. You can easily write that solution as xt is going to be equal with c1 e power lambda 1 t, here v1, plus c2 e power lambda 2 t v2. Okay, that will be the final solution. Okay, so easily we can get the solution of this first order system, whereas this equation what we considered, it was a simple example, so we can also solve this equation, not a big deal. But if suppose some complex equation is here in the form of suppose higher order term, okay, so in that case this technique, it is very useful to deal with the physical situation. Okay, so that's why we prefer this technique as well. That means the reduction of nth order equation into a system of first order equation. So similarly I can give few more questions. So let's take another problem. Take this question, y, suppose y triple dash minus 2y double dash plus 5y dash minus y is equal with cos t. So we want to convert this one into system of first order equation. So just like the same manner, we'll introduce the variable, define x1 is equal with y, x2 is equal with y dash, x3 is equal with y double dash. That's it. Okay, because this is of third order equation, so we'll go up to these three variables. Okay, now from this first two, what you can write, see, x1 dash, it is going to be equal with x2. Just see first derivative. Similarly this second two, what we'll have, see, x2 dash, it is same as x3. Two equation we are getting. Now this main equation, suppose this is equation number 1, so 1 can be expressed in terms of x3 dash, that is minus 2 y double dash, so it is x3 plus 5x2 minus x1, that is equal with cos t. So this you can write that is x3 dash, it is same as writing x1 minus 5x2 plus 2x3 plus cos t. Okay, so as a whole, if you want to write this, it is nothing but x1 dash, it is 0x1 plus x2 plus 0x3. Okay, x2 dash, it is 0x1 plus 0x2 plus x3. Similarly, x3 dash, it is same as x1 minus 5x2 plus 2x3, that is equal with cos t. Now see, previous question what we considered, it was a homogeneous problem. Now this problem, see here, because this cos t is present, now this equation can be expressed 0 plus 0 as well. Now as a whole, this is our system. Okay, and the corresponding matrix representation, it is nothing but, see, x dash is equals to ax plus ft. So where this a is the coefficient matrix 0 1 0 0 0 1 1 minus 5 2, and ft, it is our this non-homogeneous term 0 0 cos t. Okay, and obviously this x is x1 x2 x3. So this is how we can easily convert this type of equation into the system of first order equations.